Hi guys, this is the notes for chapter 8.4, which is over trigonometry. So first we're going to look at the trig ratios for each one. So we have sine, cosine, and tangent. So sine can be written as opposite over hypotenuse or A over C. Another way we could write sine, well no, let's just look at this one. I don't know why they wrote both. Okay, we can write cosine as adjacent over hypotenuse, or B over C if we're looking at the diagram. In tangent, we could write opposite over adjacent, or A over B if we're looking at the diagram. Okay, so this actually stands for SOHCAHTOA. So SOHCAHTOA. And what SOHCAHTOA does is it tells you how to use sine, cosine, and tangent. So S stands for sine, okay? O stands for opposite, H, hypotenuse. So sine is opposite over hypotenuse. C stands for cosine, A for adjacent, H for hypotenuse. So cosine is adjacent over hypotenuse. And lastly, TOA, T stands for tangent, O for opposite, and A for adjacent. So this is tangent is opposite over adjacent. So remember SOHCAHTOA. If anything you remember from geometry, you'll remember this. Let's go ahead and look at example 1. So example 1 says express each ratio as a fraction and as a decimal to the nearest hundredth. So we need to find sine, cosine, tangent, all these ones here, just looking at the diagram off to the right. So remember that sine for SOHCAHTOA is going to be opposite over hypotenuse. Okay, so we're looking at P, and P is right here. So opposite of that would be 15. The hypotenuse of this is 17. So this is approximately 0.88. Okay, let's do B. Cosine is adjacent over hypotenuse. And let's go ahead and just do, I'm going to shorthand this, adjacent over hypotenuse. Well, we're looking at P again, so adjacent to that would be 8, and the hypotenuse is still 17. So that is equivalent to 0.47. Okay, let's do tangent of P. So tangent is opposite over adjacent. Well, the opposite is 15, the adjacent is 8. So 15 over 8 is 1.88. Okay, now we're doing Q. So now we're looking at this side of the angle, Q. So sine is opposite over hypotenuse. The opposite of Q is 8. The hypotenuse is 17. So this approximately is 0.47. Cosine is adjacent over hypotenuse. So remember, we're looking at Q, so this is 15 over 17, which is 0.88. And then tangent of Q, opposite over hypotenuse, is equal to, opposite over adjacent. So opposite is 8, adjacent is 15, so this is approximately 0.53. Okay, now let's look at example 2. Example 2 says use a special right triangle to express the tangent of 30 degrees as a fraction and as a decimal. So tangent of 30 degrees is equal to opposite over adjacent. Well, opposite of 30 degrees is x. So x over adjacent to 30 degrees is x square roots of 3. So these x's can cancel, so we're left with 1 over the square roots of 3, or if we rationalize that, we get square roots of 3 divided by 3, which is approximately 0.58. So these are our answers. Let's look at example 3. A certain part of a hiking trail slopes upward at about 5-degree angle. After traveling a horizontal distance of 100 feet along this part of the trail, What would be the change in a hiker's vertical position? What distance has the hiker traveled along the path? So we're going to let measure of angle A equal 5. The vertical change in the hiker's position is x. So actually I don't need to write this because look, it's on the diagram. Vertical change is x. The measure of the leg of the opposite angle A, okay? The horizontal distance is 100. The measure of the leg adjacent to angle A. Since the length of the leg opposite and adjacent is given, we're going to use tangent. So tangent of A is equal to opposite over adjacent. So this is tangent of 5 is equal to x over 100. Well, we can multiply both sides by 100. So 100 tangent of 5 is equal to x. Well, if we type that into our calculator, we get that x is equal to 8.75. Okay. Now let's find y. Y would be cosine of 5. Let me write out the definition. So cosine of A is equal to A over H. So this is cosine of 5 is equal to 100 over y. So if we multiply both sides by y and then divide by cosine of 5, we have y is equal to 100 over cosine of 5. If you type that into your calculator, you get about 100.38. Okay. Let's look at the next part. So just like we have sine, cosine, and tangent, we have the inverse of each, okay? So you can look back at this to see some examples. So inverse. This part you're going to have to use a calculator. So the measure given are those of the legs opposite angle A and the hypotenuse. So we need to write an equation using the sine because sine is opposite and hypotenuse. So we have sine of A is equal to opposite over hypotenuse, which is 18 over 27, which is 2 over 3. In order to find A, we have to use the inverse sign. So sine inverse of 2/3 is equal to A. If we type that into our calculator, we get A is equal to 41.8. Okay, let's look at example 5. One moment. My pen won't let me write. There we go. Example 5. Solve the right triangle. Round side measures to the nearest tenth and angle measures to the nearest degree. So first, in order to find the measure of x, we're going to use the tangent ratio. So tangent x is equal to 9 over 5. So tan inverse of 9 over 5 is equal to x, which implies that x is equal to approximately 61 degrees. Okay? We can use this information to find y, because we can use 61 plus 90 plus y is equal to 180. If we subtract 61 and 90 from 180, we get y is about 29 degrees. Okay? Now we can find the distance of x to y by using the Pythagorean theorem. So a squared plus b squared equals c squared. So we have 5 squared plus 9 squared equals c squared. 25 plus 81 equals c squared. So we have 106 equals c squared. So c is equal to the square root of 106, which is approximately 10.3. There we go. We solved everything that we needed to find. Okay, and that concludes those notes.